After this demonstration I will explain how the modeling, animation, textures and video editing is all done in Blender. There are 3 textures, the cloud, the toon texture and the wire texture. The animations were rendered in 4 parts, the cloud taking 48 hours at 1920 by 1080, the toon taking 10 hours at 1920 by 1080, the wire taking 24 hours at 1920 by 1080, and finally the composite taking under half an hour. Notice how the amplitude of the wave is decreasing until there is no movement. We will start by rescaling the default cube. This will form our cloud. By adding a subsurf modifier, the cube is made more and more rounded. Set both the view and rendered values to 4. Apply the modifier and set the mesh smooth. Now add a wave modifier. Set the animation life to 250. Set the speed to 0.01. Set the width to 0.25. Finally set the height to 10. Then, add another subsurf modifier to make the result smoother. This one is set to 2. We can now see the wave. These wave values were found by trial and error and only match the specific scaling on our default cube. If you scale the cube with different values, then the wave speed and amplitude will not match. The animation is uniform. We want it to be animated so that the wave decreases. At frame 1, hover over the height box and press I to create a keyframe. Then, at frame 250 set the height value to 0 and press I to create a keyframe. The height value can be seen decreasing to 0 as the animation progresses. Make sure you are in the Cycles render engine. Then set up the screen layout with a render view at the bottom of the screen and a node view at the top. You will be able to see the render update as the material nodes change. Create a new material and click Use Nodes. We will start with the default diffuse BSDF material. Zoom in with the mouse wheel and make space by moving everything to the right. Add a color ramp from the converter menu. Add 3 new color points by using the plus sign. You can manually move them about so they are evenly spaced out. Then set each point to be a bright color. You can of course use any colors, but we are going for a rainbow type effect. I often want a rainbow color ramp to clearly show how colors are going to affect objects. It may be worth spending time creating an add-on or a Python script to generate these for me. Once the colors are specified, connect the color ramp node to the diffuse BSDF node. The object will be colored by the middle color from the color ramp. 0.5. We want the value to change based on the texture's location on the object. The default generated coordinates will do. Add a texture coordinate node from the input menu and connect it. Now the rainbow effect can be seen on the cloud object. By adding a gradient texture from the texture menu we can get a better result. To rotate the texture, add a mapping node from the vector menu. We can control the scale and location from here, and by manipulating the Z rotation value we can see the texture rotate. To animate the value, set the Z value to -90, then set the frame to 1, and hover over the Z value, press I to add a keyframe. Set the current frame to 250, change the Z value to 90 degrees, and press I to add a keyframe. We can now clearly see the animation interpolating the values between -90 and 90. Now let us add the cloud texture. Add a mix shader from the shader menu. From the shader menu, connect a volume absorption shader node to the top mix shader connector. From the shader menu, connect a volume scatter node to the bottom mix node connector. Connect this mix node to the volume connector on the material output node and disconnect the diffuse BSDF shader. This gives us the cloudiness. Connect the color output from the color ramp to both the color inputs of the volume nodes. The cloud is a bit gray, so let us increase the lighting. Select the lamp, click Use Nodes. Increase the strength to 500. Select the world icon in the tools and set the color to black. By scrubbing through the animation we can see the rainbow texture rotating on and within the now volumetric cloud mesh. However, it is still a bit too dark. There is no ambient light from the background. We can try changing the lamp strength to 800. But perhaps a sun lamp type would work better. 800 is too strong for a sun lamp. Change the value to 10. That is much better. The toon material is the easiest to create. Make room in the node layout. Add the toon shader from the shaders menu and using its defaults. Connect color from the color ramp to the color input on the toon shader. Connect the BSDF to the material output surface input. Disconnect the volume. The toon shader creates some stunning visuals with high contrast shadows and colors. It produces a vibrant effect with our rainbow cloud wave. The result looks almost flat as watch the colors move across the animating cloud mesh. To create the wire/ribbons material we need to mix a color and transparent source. Add a mix node and connect it to the material output node. We cannot use the color ramp output directly, so connect the BSDF to the top connector on the mix node. Now add a transparent shader from the shaders menu and connect it to the bottom connector on the mix node. Currently this will just make a semi-transparent material. Add a wave texture from the textures menu. Connect the output from the texture mapping node to the vector input on the wave texture node. Add a new color ramp from the converter menu and connect the wave node to it. Connect the color output to the factor on the mix node. You can already see stripes appearing on the mesh. By moving the black and white default color points in the color ramp node, we can define the size of the ribbons. Adding addition colors would have no effect, as we are just taking the brightness of value to affect the mix node factor. This ribbon effect allows us to see through the object as if the gaps between the ribbons were holes in the mesh. If we review the animation, the color rotation and wave animations still play nicely with the ribbons in place. The ribbons as they exist at the moment are a bit fuzzy. Let's fix that now. The gradient between the black and white points in the color ramp node is the problem. By moving the two color points closer together, we reduce this, and thus the ribbons become sharper. Finally, we are going to review the video composition rather than create it from scratch. This Blender session is set to the Blender internal renderer. Each video has been loaded into the video editor and has had various effects applied. These have been grouped into meta strips and collapsed, so all you can see are the main sections. You can expand a meta strip with Tab. Here is the mix of the three rendered material types, with differing transition wipes applied. Here is the first wipe transition effect. It is set to a transition type of double. This produces the expanding door effect, revealing the next video. Positioned above the first in the strip layout. Next, the transition type is iris, that creates an increasing hole, revealing the next video. The blur width can be changed to make the transition smooth or sharper. We then repeat the iris wipe transition, but allow it to reveal the next video below the last. And finally, another wipe transition type of double. Remember, this is all happening within a meta strip. Tab out of this strip, and we will look at the next meta strip. This meta strip has only one video and one effect. The effect scales the video to 1/3 its original size and translates it to the top left corner. The final video output has two of these. The second one also scales to 1/3 the original size, but translates to the top right. The three meta strips combine to make the final video, with its three source files split, and combined to make the final composition. The voiceover you have been listening to is simply the output from the Linux espeak program saved as WAV file and, you guessed it, combined within Blender. We will end with the three original video results.